Here's part 2 of the So-Vits-SVC training tutorial on how you can now run it locally on your computer. For gathering data, make sure you watch part 1 up until the point to where I start training it on Google Colab, and then come back to this video if you want to know how you get the data. With Google Colab out of the way, I believe I covered everything. We're going to go ahead and run it and install it locally. So let's go ahead and head on over into GitHub. What I assume you have installed is Python, Git, and then VS Code. You can use any IDE you want, but I use VS Code. So go watch that YouTube tutorial that I have on my channel, linked in the description down below. So what we're gonna need is, we're gonna need to clone this repository. So go ahead, clone it, and then we're gonna go ahead and navigate into a folder. So here I just have that same one, and we're gonna right click, open in terminal, so that we can see the terminal window here. So we're gonna do git clone, paste that link into the folder, and it's going to go ahead and copy everything. So now with that, we're going to go and open up VS Code. So if you have VS Code installed, it's just simply open it up, and we're going to just drag and drop this So-Vits-SVC fork into VS Code. And so here we are. You're going to want to trust the authors, so trust the authors, and we're going to head back over to the GitHub repository and follow a couple of steps. So we're going to need to do some installation, but before that, I really recommend that you do a virtual environment inside of your IDE. So for Visual Studio Code, it's Control-Shift-P to create, to bring this up, and then you're going to want to search up Python, and this create environment one should be somewhere in here. So click create environment. I'm going to use venv, and then I'm going to select and I'm actually going to select Python 3.89. So I remember reading somewhere that the newer versions of Python have issues. So to install 3.89, what we can do is head on over to Python, and once you're in the Python, once you're on the Python page, the release that we want is 3.8.9. So if we head on over to this look for specific release, we should be able to scroll down until we see 3.8.9, which is April 2021. Click download, and then you go to the Windows installer right here, 64-bit, and then you install it as you would regular Python. So go ahead and do that. I believe if you already have 3.10 installed, you can try running it on here, but I believe I saw somewhere that there might be issues with later releases. Once you have your virtual environment created, you would open a terminal window, click new terminal. You want to make sure you're inside of the So-Vits-SVC fork folder, and then type .venv. The .venv is what VS Code uses. Type scripts, activate, and I'm just doing tab to autofill it, and it's going to activate it, and you'll see it's activated by this green area over here, .venv. Let me make this bigger, and the next thing we're going to run is pip install here. Pip install setup tools wheels. Paste that, go ahead paste, go ahead enter, and it's going to install setup tools. And then the next one, we're going to install PyTorch. So go ahead, paste that in. This one's going to take a little bit of time because this is a big library, so we'll be back when it finishes. Alrighty, and so once that is installed, we can now head on over and install the repository, which is going to be pip install this. So back to VS Code, pip install, and boom. So here we go, here we have it. Everything should be installed as needed. If you need to update it, you can always just use this in the future. And yeah, so if you followed all of the previous steps, we should have all of our data already inside of your voice recorder. You should have already recorded some audio files. There is one thing that you can use inside of So-Vits-SVC fork. There is actually a audio splitter built in. It basically just does what mine does. But if you wanted to use the So-Vits version of it, you could run this option here, which is SVC pre-split, which will split it into different multiple files. And then there's also, you can do speaker diarization. So if you have multiple speakers, you can use this to try to split the dataset into multiple speakers. I haven't tried it out yet though, so I can't really comment on it. You should already have your data, and so all we need to do is run these 4 things here. So first things first, we do have to set up a couple of things. So let's say that you did all the steps from the Google Colab part, or for procuring your data, and you have your sentences, all of your WAV files. So here is my Harvard sentences folder with all of the WAV files inside of it. And so what we're going to do is we're going to copy it, navigate into that So-Vits-SVC fork folder, and then we're going to create a new folder called dataset_raw. So inside of this dataset_raw, we're going to now copy and paste in our data sets. Actually, we do need to create a speaker, so in this case I'm going to do the same thing, me, and then I'm going to move this into the me folder. So it doesn't matter what your folder structure looks like inside of me or inside of the speaker name. You just have to have data inside of here. This is just how I like to categorize it. So if I have Harvard sentences, maybe I'll have like YouTube audio, maybe singing. I can categorize those all into different directories, but it doesn't really matter as long as it's underneath the speaker name here. Once you have dataset raw done, what we do now is do SVC pre-resample. So go ahead, copy this, go back into VS Code. I'm gonna do something called CLS, so it clears the terminal window, and then paste it. So run the pre-sample, and it's going to run through that. And when that finishes, it's going to be SVC pre-config. So run that one. And this is going to be the one that sets up the configuration file. We'll do that after we run the pre-Hubert. So this is pre-Hubert right here. We want to run it as crepe. So if we scroll down here, you can see that it says run with crepe. So if you want to run crepe, the more natural sounding one, you copy this down here, SVC pre-Hubert FM crepe. So paste that in here. And while that is running, we're going to go into our configuration file and change it. So in the left-hand side over here, you can see the config.json. We're basically going to do the same thing here. So the log interval, I'm going to change mine to 2000 and have mine output every 4,000 steps. And for my epochs, I'm going to leave it at 10,000. And for my batch size, I'm going to set mine at 50 to start. This is determined on how much VRAM you have. So I have 24 gigabytes of VRAM on my computer. If you run out of VRAM, so let me show you real quick. I'll run this. I'll run the train at 100. So the tensor board is going to pop up, and this is going to happen right here. It should fail. So okay, it did not fail. Hold on, let me try one thing. If you want to stop training, just click Control C multiple times and it'll stop the training. So I'm gonna go ahead and set mine to well, I actually can't set it any higher because I don't have enough samples, but we'll see what happens when I run it at 150. Okay, so my OBS actually crashed, but here is what happens is it says CUDA out of memory. So this means that you don't have enough VRAM. Either you don't have enough VRAM on your graphics card, or your audio files are too long, or you're trying to run too large of a batch size. So this was when I was running it at 150. And so I know that if I run mine at 50 with 100 data samples, it's going to run just fine. So I'm gonna go ahead and save this. And as you can see, I was starting to train again before I realized my OBS had crashed. And if we run SVC train, it's going to start again from 0. Tensor board is going to pop up, and here we go. We'll see. I'll show you how. And then as you can see, the same bar that appeared in Google is going to appear here, and you'll see it running through your data here. So yeah, so as you can see, it is running through the data. It's only taking 2 steps to go through data here, and it's taking less than a second for 50 samples in my case. Now this changes and this varies based on your batch size, or based on your sample size. So if your sample size is huge, you might not be able to get away with 50 for your batch size. You might have to lower it. You do have to do a lot of playing around with it and seeing what works best for your situation here. So as I said, you can do Control C to exit out of it, as we're not going to train an entire new model right now because I still have to edit the video. So I need some VRAM in order to do that. Once that finishes, you will get a model. So if you open up your file browser, if you go into logs, 44K, you will get the same thing that you saw in the Google Drive. And for brevity's sake, I went ahead and copied a previous model that I had trained, this 25,000 PTH PyTorch file here. So we're gonna go ahead and just run it with this. So to open up the GUI, you're gonna type in SVCG, which is SVC GUI, and inside of here, it's going to automatically choose your model path and your configuration path. To do that, you just do browse, go to SVC logs, 44K, and then you select your model, and then in the same folder, select the configuration file. It doesn't really matter because it should automatically choose it. And then what you're gonna want to do is select the vocal file that you want. We're gonna do this vocals.wav, and then if you're training a model, you don't want to have use GPU turned on. You want to have it turned off so it uses your CPU. That is so you don't get that CUDA cores out of memory issue. And there is an interesting glitch with the GUI that will mess up your first generation because of this auto predict. It automatically gets checked back. So once I click infer, it's going to check it back for some reason, and it's also going to check back autoplay. So I'm going to uncheck autoplay here and then rerun it again after this one finishes. Okay, so this one finished. So now I'm going to officially set my pitch. I'm going to set it at 0, make sure this auto predict is turned off, make sure autoplay is turned off, and then I'm going to go ahead and infer once again. And as you can see, they stay unchecked. So this is currently, I guess, just a new graphical user interface bug that has been introduced recently. I didn't notice it when I was using it a couple weeks back, and yeah, so we'll go ahead and take a listen to those two audio files, and you'll see a stark difference in the quality of one over the other. So now let's navigate into that folder where the audio files are. Oh, so it looks like it overwrote the other one, which is vocals 4. So let's go ahead and listen to this one. I'm going to go ahead and name this one actually no auto tune. So let's go ahead and listen to this one.
Hey there, Delilah, what's it like in New York City? I'm 1,000 miles away, but girl, tonight you look so pretty, yes you do.
Okay, so that is my voice. And so now what happens if you accidentally leave auto predict on? We'll go ahead and re-infer, and you'll see what happens with this one. Okay, let's go ahead and play this one. Auto tune is on.
Hey there, Delilah, what's it like in New York City? I'm 1,000 miles away, but girl, tonight you look so pretty, yes you do.
And as you can see, that right there is much more robotic, much uglier than the other one. So you want to make sure that that auto predict frequency is off. For whatever reason, that graphical user interface bug is there when you click infer the first time around, but it goes away when you click it the second time around. So just make sure you know that, and you notice that this auto predict is off. Gotta be off. And that is how you can train a end-to-end model with your own voice for So-Vits-SVC for AI singing. You can do this with any other audio sample you want to do. You just have to make sure that you curate the data and make sure the samples are 10 seconds or less to make sure you don't get that CUDA core out of memory error message. So now there are some common questions like, what happens if it crashes while you're training? Well, that's why you set your log eval interval to a smaller amount, so that if your model crashes or if your runtime on Google stops before your evaluation interval, you don't lose all that progress. So yes, you can continue training there. If you want to train a new model, I believe you have to remove all of the previous data. So everything from like dataset raw, dataset, logs, you want to remove all those so that you have a clean slate to start from, so it doesn't start from any random log area. But there are so many different things that can happen. I don't know if I'm going to be able to cover them all, but this is how you can get started with using that So-Vits-SVC to train an AI voice to sing based on whatever data that you have. And that's going to be the end of today's video. If you found anything interesting, please leave a comment down below. If you found this video helpful, please leave a like. It helps me out. And that's going to be it. So see you guys later, and stay tuned for other stuff.